Want to test if the equation is exact. So this is now our m and y, this is our n. That's the whole of this n, the whole of this m. Okay, so we find the m, the y, that means differentiating m with respect to y. Since this is a rational function, we can use the quotient rule where the numerator is u and the denominator is v. So we can say v u prime minus u v prime, okay, all over v squared. Okay, so v now is the numerator, which is exactly what we have here. Then u prime is differentiating u with respect to y, that's y squared. That's how we got 2y here. Okay, and sorry, let's rub this off. Okay, so we have minus u, so your u is y squared, which is what we have here. Then the v prime, that's derivative of the denominator with respect to y. When you differentiate x squared y minus y cubed with respect to y, you are going to get x squared minus 3y squared. Okay, so that's exactly what we get here. Then everything all over v squared, which is what we have here. So when you open up this bracket here, okay, we are going to get 2x squared y squared minus 2y4 minus x squared y squared plus 3y4 all over x squared y minus y cubed all squared. Okay, so from here you can see that this 2x squared y squared minus s squared y squared gives us s squared y squared here. Then minus 2y4 plus 3y4 gives us y raised to power 4. And the denominator remains the same. So this is exactly what we get for the m dy, differentiating m with respect to y. Now we continue here. We have this, so you see that y squared is common, so we factorize y squared numerator. And in the denominator also, y squared is common in the sense that when you look at this, we can factorize y. For factorizing y, remember everything is carrying squared, so the y too carries squared. So what remains is x squared minus y squared, okay, all squared. That's what we have. And this is the m dy. So we continue with n. This is what our n is. So the same thing, we have to find the n dx, and that means we must definitely use quotient rule too. Which is v u prime minus u v prime all over v squared. Okay, so your u is the numerator, your v is the denominator. Okay, so our v is s squared y minus y cubed. Then our u prime, when you differentiate u with respect to x, you are going to get 2x minus y. Okay, then minus your u is s squared minus xy minus y squared. Then v prime, when you differentiate v now with respect to x, you're going to get 2xy minus, okay, just 2xy. Okay, that's because when you differentiate y cubed with respect to x, it is 0. So you differentiate this, is going to give us 2xy. So that is how we got this, then all over v squared. So we continue here. This is what we got. We can open up the bracket where x squared y times 2x gives us 2x cubed y. S squared y times y gives us minus s squared y squared. Well, proper expansion of the numerator is going to give us this. And you notice that some things here can cancel out. 2s cubed y cancels 2s cubed y. Okay, I can also see minus 2xy cubed cancel out 2xy cubed. And I'm left with minus x squared y squared plus 2x squared y squared, which is also s squared y squared. Then we have y raised to power 4 here. So that's exactly how we got this. Okay, and then when you notice here too, y squared is common. So when you factorize y squared can cancel y squared, and you're left with this, which is exactly what we got for the m dy. So we can now conclude that since partial derivative of m with respect to y equal to partial derivative of n with respect to x, then the equation is exact. Okay, so we can go on with the solution. So this is exactly what we have here, our transformed exact equation, and the solution is equal to u, which is represented as this: du dx dx plus du dy dy. So we can start with saying du dx being equal to y squared all over x squared y minus y cubed. Okay, when we make use subject of formula, is going to be integral of y squared over x squared y minus y cubed dx. Remember, we are integrating with respect to x. But first of all, you should know that y squared all over x squared y minus y cubed can also be written as y squared over the denominator here. There is a common factor, which is y, so you are left with x squared minus y squared. Okay, so you see y cancels y, so we are left with just y over x squared minus y squared. So that makes it that we are integrating with respect to this. Now there are several methods now of integrating this, but I chose to integrate this by partial fraction. Okay, so since we are integrating with respect to x here, y is a constant. Y is a constant. Okay, and so if I have my y here, that's the y, the constant y, times 1 over x squared minus y squared. Okay, now when we by partial fraction break down 1 over x squared minus y squared, we are going to get 1 over 2y, okay, into 1 all over x minus y plus 1 over x plus y. Okay, so and since we already have y initially, you see that y cancels y, and we are left with 1 over 2. We are left with the whole of this. Okay, so when we continue, you're going to see that your u now is half integral of 1 over x minus y will give us ln x minus y. Remember, we are integrating with respect to x, so that's ln. Whenever you integrate 1 over x minus a, you are going to get ln x minus a, okay, as a standard. Now minus integrating 1 over x plus y gives us ln x plus y. Yeah, whenever you integrate with respect to x, you are going to have a constant, which is a function of y. Okay, so that is what we have, and so at this point we can now differentiate u with respect to y. Okay, so differentiating u with respect to y, this you have here. Then differentiating this, remember when you differentiate ln x, you're going to get 1 over x. Okay, in the same way, when you differentiate ln x plus a, you're going to get 1 over x plus a. So that's exactly what we have here, but we are differentiating with respect to y. So in this case here, it will be minus 1 because the y here carries minus. So minus 1 over x minus y. Differentiate with this with respect to y, you are going to get 1 over x plus y. Okay, then plus differentiate ty, you get t prime y. And the whole of this, we can equate it to n. Okay, that's because du dy is n, and n is equal to the whole of this, which we can break down to this. Okay, so if you notice, your x squared minus y squared is what we have here, then minus xy over the same denominator. They have common denominators. Okay, we just decided to separate them that way, and if we do that, we are going to get this 1 over y minus x over x squared minus y squared. That's because your x squared minus y squared here cancels x squared minus y squared, so leaving it with 1 over y. Then this y here cancels y here. That's why we have x over x squared minus y squared. Okay, which is the same thing as, just like I showed us the partial fraction, we can break this down into partial fraction, to get this. Okay, so at the end of the day, we have this, and so when you compare this with what you have here, you see that every other thing cancel out. The whole of this cancels the whole of this, So you are left with t prime y equal to 1 over y. And if t prime y is 1 over y, it means that ty now will be ln y plus c, okay? So ln y plus c, because integral of 1 over y is ln y plus c. And we started by saying your u is equal to the whole of this. And so we can substitute the value for ty, which is ln y plus c. Please do well to go through our previous videos, especially the initial one we started, so that you can get a complete understanding of exact equation. Thank you very much.